All right, we're going to do properties of logarithms. We've done this section a little bit already. We're going to be going over the product, quotient, and power properties of logarithms. We've done change of base already. And I've actually gone over all of what's in here in another video, right? But this is what I had showed you guys in class, right? So this is going to reflect that information. It might be a little bit easier for you guys. All right, so here's some properties of logarithms. Stuff that I didn't go over in class, but I went over in the previous video. We have the product property, which states that if you're multiplying under a log, then you can split it up and it becomes an addition problem, right? So in any of this, if you have multiplication inside, all right, that's going to become addition outside or between two logs, right? Similarly, if I have a quotient property, so if I have log base b of m over n, remember this m over n, this is the same as m divided by n, right? If with multiplication you add, with division you subtract, right? So again, if you have division inside a log, that's going to give you subtraction between two logs. All right, and if you have a power property, log base b of m to the power of n, right, that n, that exponent is going to go out front, right? So if you have an exponent, that's going to go out front. All right, and we'll do some examples where this is useful to us. So for example, sometimes we're given certain values, and you're going to see in the next slide that we're going to be given certain values to plug in, right? But because we know our product, quotient, and power properties, some of these properties are going to be useful in making the expression a lot simpler and make it into something that we can evaluate with some given information. All right, so this is one example of where our properties of logarithms are useful in evaluating something, right? So let's say you didn't have a calculator and you wanted to evaluate this 3 divided by 7. I'm sorry, log base 2 of 3 divided by 7, right? So I'm looking at part A. You can't really do that without a calculator, but we do know that log base 2 of 3 is approximately this value and log base 2 of 7 is approximately that value. And because here I have a division, right? So division inside of a log, right? So I have a log base 2 of 3 divided by 7. Remember, this is all what's inside of our log. Then this division is going to become a subtraction between the logs, right? So I can go ahead and split it up. I'm going to have a log base 2 of 3 minus log base 2 of 7, right? And these are values that we have. We're given log base 2 of 3 and we're given log base 2 of 7, right? So I'm going to say that this is, well, I guess I should say approximately 1.585 minus 2.807, right? So if you work this out, you should get that this is 1.222. I'm sorry, negative. All right, now that's not something we would have been able to do without a calculator if we weren't given these values to begin with, right? I know with a calculator you can probably just put this in, and with the information that I taught you in the previous lesson, you could use change of base formula to rewrite it and evaluate it with the calculator, right? So now if you look at part B, I have a log base 2 of 21. I don't know what that is, but I do have a log base 2 of 3 and a log base 2 of 7. We're able to write 21 in terms of 3 and 7, right? So 21, you can write this as log base 2 of 3 times 7, right? And remember, if you have a multiplication on the inside, that becomes addition outside between your logs, right? So this is going to become a log base 2 of 3 plus log base 2 of 7, right? And I have that this is approximately 1.585 plus 2.807. All right, so these are values that we were given. All right, and if you evaluate this should get you 4.392. All right, and if you look at part C, I have a log base 2 of 49. 49 can be rewritten in terms of 7. Right, so you can do what we did in part B and say that this is log base 2 of 7 times 7. Right, but another way to write 7 times 7 is 7 squared. So I have a log base 2 of 7 squared. And now we can use our power property, right? This exponent is going to go out front. Right, so we get 2 times log base 2 of 7. And so this is going to be approximately 2 times 2.807. And that's going to get us 5.614. Right, so hopefully we see that in these examples, the properties of logarithms are pretty useful if we're given some information, right? We're able to manipulate each expression into something to where we can use information that we already know. All right, so these are going to be done in the exact same way as we did the previous slide. If you're seeing this for the first time, I know a lot of you are away. I would highly suggest you try some of these first before watching the rest of it. So try it and see if you can do the rest of them, right? Try 1, 2, 3, and 4. All right. For number 1, look at what we have on the inside. I have a log base 6 of 5 divided by 8, and then that division is going to turn into a subtraction between your logs. So this is going to become a log base 6 of 5 minus log base 6 of 8. All right, and these are values that we're given in the problem, right? We're given that log base 6 of 5 is about 0.898 minus, and I know that log base 6 of 8 is approximately 1.161. All right, so I get, this is going to get us negative 0.263. All right, so we expanded that quotient inside of the logs into 2 separate expressions, and then we combine our answers. All right, we can do the same thing with the next one. All right, if I have a log base 6 of 40, I don't know what that is, but I do know that 40 can be rewritten as 5 times 8. So this is going to get us a log base 6 of 5 times 8, right? And remember, times on the inside of a log is going to become an addition outside of the log. So this is going to become a log base 6 of 5 plus log base 6 of 8. All right, and then this is approximately, I know that log base 6 of 5 is 0.898, and log base 6 of 8 is 1.161. All right, let's see what this gets us. All right, this should be 2.059. All right, number 3, same thing. We have log base 6 of 64. I don't know what log base 6 of 64 is, but I know that 64 can be rewritten as log base 6 of 8 times 8. Now, from here, you could do log base 6 of 8 plus log base 6 of 8, or you can write it as an exponent. We have a log base 6 of 8 squared, and this square over the 8 can go right in front of our log base 6 of 8, and this is going to get us 2 times log base 6 of 8. And I know log base 6 of 8 is about 1.161, or let me say approximately. All right, so we get that this is 2.322. All right. All right, and then same thing for number 4, log base 6 of 125. I don't know what that is, but I do know that 125 can be rewritten as 5 times 5 times 5, or 5 cubed. right? So this is going to get us log base 6 of 5 to the third power. And then this 3 can go right in front of our log base 6 of 5. All right, so this is 5 times, whoa, sorry, not 5. 3 times log base 6 of 5. All right, let me say that this is approximately 3 times 0.898. And this is 2.694. All right, so problems that don't ask you to evaluate are problems that are going to ask you to rewrite an expression either by expanding or condensing. Right? Expanding, what does that mean? Well, it just means to make something bigger. Right? So if you see one singular logarithm, and I'm asked to, like for this one, I'm asked to expand ln of 5x to the 7th divided by y. Well, the goal here is to write as many logs as possible. I want this to be a big expression. Now, condensing, on the other hand, all right, the slide after this, we're going to have a problem on condensing, and that just means to make smaller. So you're going to have several logarithms in a single expression, and your goal is to write it as one single logarithm. All right, so let's try this example. I like to tackle these by first identifying what operations are being done inside of your logarithm. So inside of my log, I see a division. I know that that division is going to become a subtraction. I see on top 5x to the 7th. That's 5 times x to the 7th. That's going to become a plus. All right. And then I see a 7th in the exponent. That's going to go in the front. So I should expect my final answer to have 1 plus, a minus, and an exponent that's moved to the front. All right, I'm going to start just by whatever is being divided, just because that's what's happening to the top and the bottom. So everything that you see in this expression is being divided. So this is going to become an ln of 5x to the 7th minus ln of y. All right, so we took care of that minus, right, that division. Now I see that there's a multiplication. I want to take care of that. All right, so we can split this up to be ln of 5 plus ln of x to the 7th, and then I still have that minus ln of y. All right, and so we just took care of that multiplication, and then now I want to take care of that exponent, right? So I see an exponent over that x, and that's going to go to the front. All right, so then this is going to become ln of 5 plus 7 ln of x minus ln of y. And then that's as simple as we can get, right? And you can tell if you're done just by checking in the inside of each log. Is there any products? Is there any exponents? Is there anything that's being divided? All right, and the answer is no, and we did account for everything that we originally anticipated. All right, so that's how you can tackle these log expressions. If you're trying to expand it, I like to first start with any division and multiplication first, and then do your exponents. When you're condensing, it'll be the opposite, unless, of course, you see any sort of parentheses around it that implies that you should be doing that first. Then, of course, you would do that first, right? But let's try some more. All right, so we can keep going with these examples. Notice in number 5, we have a multiplication. I see that it's a 3 times 4 x to the 4th. And then that multiplication is going to become a plus between logarithms. And then you have a 4 in the exponent that's going to go to the front. All right, so first I would split it up. So I would get log base 6 of 3 plus log base 6 of x to the 4th. And then to the 4th power, this 4 can go out front of my log base 6 of x, and then it's going to become a log base 6 of 3 plus 4 log base 6 of x. And there's your fully your fully expanded expression. All right, and you know that you're done because if you look inside of each log, there's nothing else that you can multiply or divide, or there's no more exponents, right? That fully accounts for that plus that we originally established and the exponent in the front that we originally established. All right, so we know for sure we're done. All right, so something like number 6 then, it's another one where we have multiple operations on the inside. So if you look, we have a division. That division is going to tell us to subtract between logarithms, and then I have a multiplication underneath that's going to tell us to add between logarithms. Right, so I would first take care of that division, just because that's what's being done to this entire thing, right? That multiplication is only being done within something that's being divided. So I would have an ln of 5 minus ln of 12x. And then this 12x is a 12 times x, right? So we already took care of our minus, right? Now that 12 times x is going to become ln of 12 plus ln of x. And then we can bring down the ln of 5. But keep in mind that minus, the way that I wrote it right now is not correct. We need to make it clear that we're subtracting this entire expression in blue. So I would put it in parentheses, just so that when you go back, if you were to go backwards, let's say, and you wanted to put it back into a single logarithm, so you wanted to put it back into something like that, you would need to know to multiply the 12 and the x first before you divide it, because otherwise you could risk the x being out on top with the 5, and that's not what we want. We want it to be in the bottom. All right, so this right here is our fully expanded expression. All right, so condensing, we're going to do kind of the same process, just in the opposite direction. So condensing means to make something smaller. So we're going to rewrite this entire expression that we see here into a single logarithm. All right, so I would do kind of the opposite of what we've been doing. Recognize what operations are being done between the logs, and then try to make it so that they're happening inside, right? So I see a plus, I know that that's going to be a multiplication. I see a minus, I know that that's going to be a division. And I also see a 3 out front, I know that that's going to become an exponent. All right, so I would do the opposite of what we did in the other examples. And I would first do my exponent, right? Just because I'd want to make sure that that exponent is over the correct number in this case. So we get a log of 9 plus log of 2 to the third power minus log of 3. All right, and now that we took care of our exponent, that's done. All right, I want to take care of this addition, which is going to become a multiplication. Now what we're going to be multiplying is what's inside of the logs that the plus is between. All right, so this is going to become a log of 9 times 2 to the third power, and then I have a minus log of 3. All right, and then again, keep in mind there's a minus in between it, so that's going to become a division. I always go from left to right. All right, so we have a log of 9 times 2 to the third over 3. And now this is the fully condensed expression, but if you have numbers on the inside, you want to make sure that you're fully simplifying it. So this right here, this is fully condensed. If you can get there, then you're able to condense properly and correctly. But we do want to fully simplify what's on the inside. Keep in mind that 9 and 3 are going to cancel out, and that's going to become a 3. And then 2 to the third is 8. So we get a log of 3 times 8, and 3 times 8 is 24. So this is going to get us log of 24. All right, so this big expression that we originally started with became something really, really small, right? We just have one singular log with just one thing inside of it. All right, so that's where condensing gets useful, right? It's to making expressions look a lot simpler. All right, let's do the same thing with this one, right? So in this one, number 7, I see what operation between that log of x and that log of 9. That is a subtraction, right? And that subtraction is going to tell us to divide. So this is going to become log of x divided by 9. All right, that's the only operation that I see. I don't see anything else going on here, so there's nothing really special with this one. It just becomes this. All right, and then if you look at the next one, number 8, we have something similar to what we had in the previous page with all these numbers. Let's see if we can make it into something simpler, right? So again, I see a plus in between that's going to tell us to multiply. I see a minus in between that's going to tell us to divide. I see a 3 in front of this ln of 3, and that's going to tell us that it's going to go up top as an exponent. All right, so again, that's the first thing that I'm going to do, is going to make this an ln of 3 to the third power. All right, and then after that, right, I'm going to bring everything else down. right? That plus is going to become a multiplication. So I'm going to multiply the 4 and the 3 to the third. I get ln of 4 times 3 to the third, which I know that that's going to get us 27, right? So you can leave it as 4 times 27, and then minus ln of 12. All right, and then that minus in between is going to become a division. So I get ln of 4 times 27 divided by 12. And then this right here is fully condensed, but you do, of course, want to simplify whatever's on the inside. All right, and then 4 and 12 are going to simplify. That becomes 1 and 3. And then so we get ln of 27 over 3, and 27 over 3 is 9. So this expression, this really complicated expression that we had in the beginning, really just becomes ln of 9. And that's it for expanding and condensing, right? Condensing, we just want to make it into a smaller expression. Expanding, we want to make it into a bigger one. And to do that, we use our properties of logs, the power property, the product property, and the quotient property. And then we also use these to evaluate some values given some information.